All right, everyone, here we're going to talk about an example of a U.S. geological stream gauging station, in this case along Coal Creek near the Southern Utah University campus. Now, when we think about hydrological measurements in the field, one of the most important instruments that we have is the stream gauge. It basically gives us continuous information on the flow of water in a watershed. Now, when we think about a USGS stream gauge, and there's thousands of these all over the United States, because water is so important as both a resource as well as a hazard when it comes to things like flooding. So we really want to have accurate measurements of the water flow. So when we're looking at selecting a site for a stream gauge, we want to pick a spot that is going to be sort of conducive towards these quality measurements. And when we're thinking about a river, what we want is a relatively simple channel. Not a lot of variation in the flow across the channel, not a bunch of eddies and things like that. You basically want the flow moving downstream in an orderly manner, makes it easier to measure. You also want a site that's relatively stable. And so, for example, at this site, we can see where they put some concrete into the bed of the river so that the channel doesn't erode down during floods, because that would affect the measurements that are being made at the gauge. And so oftentimes you'll see these things set up in places like bridges where the cross-section is going to be really stable and the flow coming into the location of the gauge is fairly constant. Now, when we think about what a gauge is actually measuring, it's not actually measuring the discharge directly. How do we actually get a discharge measurement? Well, the two things we need are the area of the flow. So that would be like a width times the depth, which we can get pretty easily just with a tape measure or ruler, something like that. Then we also have the velocity. So we need to know the velocity of the flow to convert our measurements into a discharge. So the area would be like a square meters and the velocity meters per second. And that gives us cubic meters per second, or the discharge. So when it comes to measuring velocity, that's part of the hard part of discharge measurements. A couple different devices we can use. The simplest one is something called a current meter, which is sort of like an anemometer that you see measuring wind. Same idea, except applied to a river. All right, that'll give us the velocity of the flow. These days, we also have some more complicated instruments. One is called an acoustic Doppler current profiler, or ADCP, which basically sends sound into the river and uses the Doppler effect, the Doppler shift associated with the flowing water, to compute the velocity of the river itself. And so either of those instruments can be used. In this class, you'll be working with a little bit of current meter data later on in the course. So once we have our velocity measurement and our area, we can get the discharge. Now, I already mentioned it, but the gauge itself isn't actually continuously measuring discharge directly. There's not a current meter or an ADCP out there all the time. What's actually happening is that the gauge is measuring the height or the stage of the river. And then periodically, hydrologists will go out and measure the velocity, get the actual discharge corresponding to that stage. And if you get enough measurements over a big enough range of discharge, you end up with something called a stage-discharge relationship. This is why we need the channel to be really stable, because as we're developing this relationship, it's only correct for the dimensions of the channel for which you established it. That's why you don't want the river channel to change. Once you have that stage-discharge relation, you can monitor the stage, and that'll basically give you a continuous measurement of the discharge by using that equation, by using that relation. So when you think about the gauge house itself, within the gauge house, essentially we have the instrumentation to monitor the stage in the river, or the height. We'll talk a little bit about some of those techniques later on. But we also have instrumentation up on top of the gauge to basically beam that data real time back to the internet. So things like solar panels to send that information back to us at our houses or wherever so we can analyze and monitor the discharge of the river. Now, last, I just want to mention that there's some additional measurements that you often see made at a stream gauge. Things like precipitation. We can actually see a precipitation gauge here on top of the Coal Creek gauge, but also things like temperature, conductivity, turbidity, dissolved oxygen, other information that can be important when it comes to things like water quality or health of the river itself. And so we'll be working with some of that data as well as we go through some of the modules this summer.